The intuitive software interface to the Precision Atomics Metallifier sputter coater has been designed to minimize the chance of operator error and to greatly simplify the sputter process. Single-click pump and vent operations eliminate the risk of pump damage due to operator error. In this video, I will demonstrate the sputtering of ITO, titanium dioxide and zinc oxide. To begin the process, the system is vented in order to load the samples and sputter targets. On pressing the vent button, a series of operations are executed. First, the turbo pump is switched off. This is followed by the backing and gate valve closing. When the system has reached the required state, a valve opens to admit dry nitrogen vent gas. The valve states are indicated by moving chevrons in the system diagram. The chamber pressure rises to atmospheric pressure, at which point the door can be opened and the samples and targets loaded. 2 degrees of freedom hinges ensure that the system cannot become overpressured. When the samples and targets are loaded, the door is closed and the chamber pumped down. A single press of the pump down button raises a confirmation dialog. When the operator confirms that the door is closed, the pump down sequence begins. The roughing valve is opened and the chamber is roughed down to turbo pressure. During this process, the operator can set up the desired recipe. The targets which have been loaded into each magnetron are selected from the magnetron drop-down boxes, which are linked to the target tracking table in the SQL database. After setting the target positions in the magnetron icons, the recipe can be generated. First the sample is selected, followed by the target. The desired gas flow rates for argon and oxygen are entered, together with the desired process pressure, which is regulated by a PID-controlled baffle in front of the turbo pump. Optional settings for pre-sputtering to clean the target can be entered. Finally, the sputter power and time are set. The next recipe step can now be entered. An unlimited number of recipe steps can be entered, allowing the production of complex multi-layered systems such as Bragg stacks. The recipes of each user are stored in a database and can be recalled later for another identical sputter session or altered to change sputter parameters. Once recipe entry is complete, the process start pressure is entered. The recipe is started and the system waits until either the required pressure is reached or the operator skips the wait for pressure recipe step by pressing the skip step button. While waiting for the system to pump down, the operator has the opportunity to enter a short description of each sample in the chamber, together with the purpose of the recipe. While the description is being entered, the system continues to pump down and enters the fine pumping phase. The recipe valve is closed, the backing valve opened, turbo pump switched on, and the gate valve opened. When the start condition is reached, recipe execution begins. The PID throttle control is activated and the sample moved under the required magnetron. The head shutter is moved opposite to shield the magnetron output during the pre-sputter period. The MFC set points are changed and the process gas valves switched on. After a short wait, the magnetron PSU is set to the required power and the relay to the desired magnetron activated. The interface gives a visual indication when the plasma is active. When the pre-sputter period is over, the head shutter rotates to expose the sample for the required sputtering time. The bar in the recipe generator indicates the progress through the step. When the sputtering period is over, the head shutter rotates back to cover the target and the system is purged before the next recipe step. After a purge of 3 minutes, the shutters move to bring sample 1 under the titanium target in magnetron 3. In this case, titanium dioxide is to be sputtered, so both argon and oxygen process gases are introduced into the chamber. The process pressure is set to 3 times 10 to the minus 3 millibar. The target is shuttered and pre-sputtered for 60 seconds before sample exposure. After the pre-sputter period, the head shutter moves to expose the sample to the magnetron. The power, voltage and current provided by the magnetron PSU are available as readouts on the PSU virtual interface. When the sputtering is complete, the head shutter covers the magnetron and the plasma is switched off. The chamber is purged in preparation for the next recipe step. When the purge is over, sample 2 is moved under magnetron 2, which contains zinc. In this part of the experiment, 3 quartz samples in positions 2, 3 and 4 will be coated in different thicknesses of zinc oxide to see how the film thickness affects the optical properties. The argon and oxygen flow rates, process pressure and power remain the same throughout the experiment, which varies the exposure time for each sample. When the pre-sputter period has elapsed, sample 2 is exposed, and then the shutter is closed and sample 3 moved under the magnetron. The purge step is no longer necessary, as the material for this step of the experiment is the same. The process is repeated for sample 4. When the sputtering of sample 4 is complete, the shutter closes and the magnetron power is switched off. The chamber is purged for 3 minutes and the recipe is over. The system remains in fine pumping mode until the operator vents the system to retrieve the samples. Each operator can view process data for any of the recipes which they have run by clicking the View Process Data button. This brings up a list of all recipes run by the operator currently logged into the system in a grid. The grid on the right holds a short summary of each step in the recipe, and graphs display pressure versus time, power versus time, shutter angles, and the voltage and current of the power supply. The graphs can be individually zoomed and scrolled, and hovering the cursor over a series will provide XY data information. All data is also available for export if required. To recall a previously executed recipe, the Load Recipe button is pressed. This brings up a window with a list of all recipes executed by the operator currently logged into the system. Clicking on a recipe line brings up a short summary of the recipe steps. Clicking OK will load the recipe, and the operator is requested to load the required targets into the magnetrons. Recipe parameters can be altered if desired. Manual operation of the system is also possible. Valves can be opened and closed by clicking on their icons, and MFC flow set points changed by entering the required set point in the set point box on the MFC. The pressure set point is altered by entering the required pressure in the turbo throttle valve control. Shutters and stage can be rotated clockwise or anti-clockwise using the shutter controls. Magnetron power is controlled through the Magnetron PSU virtual interface. The magnetron relay is energized by clicking on the magnetron icon. The operator wants to sputter ITO onto the sample in stage position 2. The sample is moved under magnetron 1, which contains ITO, and the magnetron shuttered for pre-sputtering. A power of 50 watts is set on the power supply virtual interface, and the power switched on. The output voltage rises to the compliance level of 800 volts. The relay connecting the power supply to magnetron 1 is activated, and pre-sputtering begins. When the desired pre-sputtering time has elapsed, the sample is exposed and sputtering begins. The sputtering time is shown on the step timer. Once the desired sputtering time has been reached, the magnetron is shuttered, the relay opened, and the power switched off. This concludes the introduction to the Precision Atomics Metallifier sputter system. For inquiries or to request a quote, please email sales@precisionatomics.com. Thanks for watching.